Good morning, good afternoon, or good evening, depending upon where you live around the world. Today I am contemplating interviewing my typewriter. That's a saying for when people don't really do the research and they just think up an idea and they act as if it is real. And I'm going to do the same thing. The question I pose to myself is, why go to all the bother of creating such an elaborate procedure for something that should be able to be done with basic tools, maybe a couple of jigs here and there in the workshop, and the accuracy would be good enough for the project in mind? I asked that question many times, and I have to justify what I do in light of that. When I see other people building the domes, quite good sized domes, and don't seem to let complexity stand in their way. Similar to the project we've got actually on screen at the moment is, while I'm using a metal hub, which itself demands maybe a little bit more concern or complexity in the procedure to drill metal, I see other people using high density polyethylene or some such material for the hub, which can be very easily machined, cut with hand tools if you wished, screwed through easily, and they get their end result. I asked myself again, David, why not just go and do what they're doing and move ahead? Point. This is metal. It requires more demanding procedures, as I've said before, and if I wish to replicate this many times over, I need to have something that's not simply accurate, the way I've been banging on many times in videos, but that it can produce multiple items in succession. And it may be that if, just for instance, I wanted to make 2 domes or 3 domes or 20 domes, the need for procedures and jigs to achieve your end purposes becomes ever greater, or the demand becomes it increases. That's my brain goes there almost automatically every time. I don't make my life more complicated out of sheer sadistic pleasure. That's not the case. But we went from this, well, actually we come across to, excuse the zooming in and out, we started off with perhaps having to create something like this to get our accurate alignment for our holes. And then through watching people like Brian Proctor and some other sites, I thought, oh, hang on, I can take something that is complex and involved and simplify it. I then required certain measurements that I took from my models, which becoming more and more refined as I develop it. And then I thought, right, let's make a jig that allows me to create the accurate radially placed holes on my hub. And complexity increased a little bit. And then I thought, do I really want to do this? And because I enjoy this process, I kind of, oh dear, look, what have we got now? Here we've got a model that I took from one of my other projects where it shows a drill press, but this time I've actually installed my jig grouping I was trying to think of the word, but a jig that we've had in other videos in a drill press situation. Now, at the moment, there's a reason for this gap. At the moment, what I'm doing is trying to indicate how to accurately do what I want for my dome project. But also in the back of my mind, I'm thinking, it's not just the jig that I want to develop a few ideas. So I've got other projects in, how would you say, they're fermenting. They're already underway, and I thought, oh, this could actually be something that I need to develop for those projects. So that's why with some of the other issues around those projects, I thought these types of jigs and procedures to make these accurate holes is worth the additional effort. So as I said, I enjoy this. It's as much to exorcise that demon of how we achieve it than anything else that makes me go down this extra route. Point: how do you get the physical location of the very top of your what do you call it, the hub, the circular hub? Well, it's quite easy, and this comes from other videos that I watched of engineers and lathe processes, how they get their tools to be exactly at dead center of a rod or a tube. Now, I transferred that logic from watching, and this is the thing, a lot of the projects like this one is not simply for a dome, and the information that I gained watching the engineers with lathes allowed me to see how I could make it used or is usable in this situation. And that's if you want to get the very top and center of a tube. Now the beauty is it doesn't matter the orientation in the horizontal plane, so you could twist it backwards and forwards on your drill press base. But if you take, and this is I'll just get rid of, hide that for a moment. Oops, what have we got there? We hide that. This little tube here with the pointy bit is actually just a tip out of my scriber that I've got in the workshop, one that you quite often will use for etching maybe a bit of metal. So I took the tip out of the scribe, put it in the chuck, so that when you move the jig sideways, when it touches the top of the tube, you know you're dead center of the circle. I hope you're following. This is how the engineers align it. When, if you imagine this, everything was tilted to the side 90 degrees, and their tool post has an indicator or a tool that approaches the steel tube. So this is in the lathe, as it were. This would be turned around 90 degrees, approaching the side, and as this very tip, in this case it would be their cutting tool, touches the edge of this the rod or the tube, that's dead center. Ditto for a drill press. So as I move my jig sideways, as it just starts to snick, that's a technical term, snick the top of the tube, you'll see, and there's another way of doing this, you'll see the chuck and the scribe just touching, and maybe you'll be able to even feel it. So as soon as you do that, you pause your jig and you clamp it down. Following? I'm actually going to have to start making live video recordings for this. It's much easier to watch something and then understand it than rather than describe it. Okay, so once that has occurred, you know where your dead center line of the tube is. You clamp it off on your base of your drill press, and that's what this. There's a reason. As I said before, there's a reason for this gap. And it's got to do with this board at the back here. But bear that in mind. We'll get back to it. My aim is not to confuse you, but confuse you I will, no doubt. Okay, once you've got that center line, you've clamped everything off, you can whip out this, so you can make that go away, and you replace the scribe tip with your center drill. Now, if I grab everything like there and move it back approximately to there, that's what we'd normally have. Don't worry about these wee bits and pieces, I'll just hide those for just now. So that we'd be in this same position here, where once we had the scribe in our chuck, we've now got our center bit, and it is dead in line with the top of the tube, the line of the tube, and because it's in the front, you've gauged it to, you've registered it in position. Now, because we've got a block at which we can push our jig back against, that registers it in the backwards and forwards position. As I say, I think a live recording of this would be easier. Okay, now if I move everything forward, let's just see if I can grab everything that's required. Don't worry if I don't grab everything. This is just I haven't grouped. This is the first time I've actually shown this. But if I move it forward, let's just say 50 millimeters, by gauging it off this block, I know this is my first point at which I can drill my hole. I know that the next hole has to be 3.3 millimeters higher. How the hell do I do that? Well, because we've got these little items here, which should be really a video onto itself for how it's used, I can dial these in. I can rotate them 3 1/3 times each. So if I turn, and these are 6mm metric threads, and a 6mm metric thread has a 1 millimeter pitch. So one revolution of the knob means 1 millimeter. So I can rotate these 3 1/3 millimeters, and that moves this forward 3.3 millimeters. I can register that quite in a coarse measurements in some ways on the rule that's built into the jig, but by use of a thread you can get more accuracy than you can by reading it by a physical measurement. The other way of doing it is having dial indicators, so that as you move you can get it down to the 100th of a millimeter if you wished, and there'd be no reason for not doing that if you had a job that required that. This one doesn't require that level of accuracy, but we can go down to the 1/10th of a millimeter by knowing how many rotations or part rotations thereof of the knobs, which have got a 6mm thread which has got a 1mm pitch. Pretty damn cool, huh? And the point is that in the pursuit of accuracy, we also need to be able to do it easily. To have something that's overly complicated, sorry, it's getting late at night, but if it's too complicated, you're not likely going to use it. This, despite its apparent complexity, is very, very simple. So really, at the end of the day, we want to be able to produce our hub, whether we're using high density PVC, high density polyethylene or steel, and as you go up in hardness, of course, the demands become a little bit more demanding, but also that, as I mentioned earlier in this particular video, that if I wanted to produce more than one item or repair or replace or extend a project like a dome, I need to be able to replicate it and have a method and the jigs to be able to do that. One-offs, well, you could probably do it with a hand drill and a handsaw, but multiple items of high accuracy, repeatability, and multiples require more demanding jigs and processes. Hence, my brain goes straight there and I overcomplicate it, but with in the background all the time that idea of those parameters that require this sort of thing to occur. This model was taken from 3D Warehouse, which I love. It's a great facility, but now unfortunately there's restrictions on the SketchUp Make. I used to be able to download whatever I want, but for some reason that has stopped working. Here I wanted to find out how to drill a center in a round piece of stock, and there is a process for doing that, but it becomes a little bit problematic, and really that's what you use lathes for. But just between you and me, don't tell anyone else, but I don't have a lathe, and a lot of people won't have the tools that's required for many of their jobs, so sometimes we have to fudge another method of doing it. And this was the project that I did some months ago, where I had to drill dead center of a piece of round stock, as I said. So there you go. That's where we're at for this. This is just the hub for a simple dome, which is really just a bit of landscaping, but why on earth do we have to go to that? Well, hence I interview my typewriter, I ask myself a question, and I try and come up with a plausible reason. Okay, well that's it for this one. I went a bit longer than normal. I hope that you get where I'm coming from when I do these projects and the videos for it, and hopefully you'll get something from it. If not, you've just wasted 18.5 minutes of your life that you'll never get back. Sorry about that. Okay, see you later. Bye.